Okay, I don't know how long this video is going to be, but basically, I was just wiping off the board, and basically, this is a good example of what I mean. So now, while I was wiping like this, think I have fingers, right? So my wiping power is not evenly distributed. There's spaces in between, right? So I came up with this pattern, obviously. Although I was wiping the exact same material, these wave patterns showed up. So I'm asking you what this looks similar to. In my opinion, it looks very similar to the double slit experiment and how these waves propagate and stuff. I would say it's the pressure of the universe itself. The pressure of the fingers on the other side that made it line up in that manner, right? Despite all the fingers going across, it accumulated on the pressure of the fingers through the cloth. I'm saying these cloths are dimensions. I'm saying depending on where the pressure is coming from the other side is where you're going to accumulate most. So I'm saying to understand dimensions, you have to understand, I guess, anti-dimensions, right? So the Casimir plates in that experiment, it's this fault line that comes in between. Now, I'm probably going to have to draw an example here. Hold on. Okay, basically what I'm saying is, I was watching a video the other day that said, in string theory, they have it mathematically, string theory, 11 dimensions, mathematically. All versions of string theory are correct. And I'm saying that's because they're describing the exact same effect observable in every dimension. I'm saying math is infinite. Understand that. I mean, you already know this intuitively, but you keep forgetting that you know this for some reason. You keep saying, for example, you're like, pi, what's the next number? And you're just like, oh, it's this. I'm saying, you're just wasting your time. You're just making this, okay, it's hard to draw with one hand, I will admit. There. You're making this hypothetical circle, this circumference, you're making it infinitely smooth by doing this process. So I'm saying, you already understand you're making this infinitely smooth. So what are you doing? Seriously, what are you doing? I'm saying, if you hold a sphere, you don't have to know what pi is to hold a sphere. The universe exists whether or not you can mathematically define it. So when Albert Einstein felt uncomfortable about quantum mechanics, where he's like, well, your maths make sense, but your physics don't. It's because particle physicists are doing this exact same thing. They're just going new particle, new particle, new particle, new particle, new particle, new particle, new particle. I'm saying the universe's dimensions, let's say first dimension, second, whatever. In every axiom, every single way you can slice it, you're just making all these dimensions, you're just adding more dimensions. You're making this metaphysical smooth, infinitely smooth circle. Because you misunderstand that dimensions coalesce like this, like everything does due to the force of gravity, right? I mean, if you put random materials out in space, they'll all coalesce into the center point. I mean, everyone knows this, or should. So while you think dimensions are like flat lines, like A, B, C, D, E, F, G, H, I, J, K, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because of string theory and that's all your math got you to, I'm saying think about it. It's not because there are 11 and there may be a potential mathematical 12th. It's not that at all. What I'm actually saying is that it's dependent on how you define them, not how many there are. Because I'm saying, if you understand Sean Carroll's many worlds interpretation or theory, if you understand that, see, hold on. I hate where the mic is placed on this because it's very hard to hold this because phones just keep getting bigger and bigger and bigger. I don't know why. Inability to understand all this, perhaps. Anyways, if you understand Sean Carroll's many worlds theory or interpretation, then you understand that there's already infinite amount of dimensions or alternate dimensions or parallel dimensions or parallel universes or all of that stuff. You understand that already. So I'm saying, why are you linearly defining them when you don't understand that they're not linear? This is a one-dimensional understanding. See, I'm only adding the line to show you where the boundaries of it, but I'm saying the dimension is vibrating. So imagine for a second it didn't have another line through it and that they were just waves. That's what string theory is. That's literally what it is. And I'm saying you're defining these strings like the greens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then you're going to get to 12th. And then you're going to get to 13th. I'm saying stop. Stop and think about it. This is really the center point of everything you've considered. If you're just going to make a 12th. I'm saying think about the median. All of these are interacting with each other at this middle point. Do you understand what I'm saying? Perhaps I could erase some stuff and show you. Okay, does this start to seem a lot more familiar? At least to those scientifically minded. It's the Casimir plates. It's literally the Casimir plates. I'm saying the dimensions act as soft, porous Casimir plates, okay? Here and here. But what you don't understand is where all the particles are popping into existence is on this fault line in the middle. Okay? This is where the quantum fluctuations are happening in between here. It's from this fault line that's pushing all this other stuff. And I'm saying it doesn't matter where you define the edge of your little experiment here. It's always the fault line of the dimension, the zero, the middle dimension. This infinite, I don't know how else to explain it. It's this point right here that's spawning everything. And then you just keep adding off to the side thinking you're going to figure this out more. You just keep adding, how many more dimensions can I make on either side? Or how far can I keep going? I'm saying, no, look at the middle point. The goddamn thing that's spawning all this. Sorry. So you can think of it as like a fault line. So like a zipper, and like everything's pew, 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 pew. And you know, everything bounces off the plates, right? And it creates this activity within. So now hopefully you understand quantum fluctuations better because you looked at string theory. What I'm saying is that what you don't understand is this linearity is a false dichotomy. I'm saying this rift occurs, but you also have to realize that the dimensions are wrapped around in a circular way. Perhaps that could be another video, but Casimir. See, that was a Freudian slip right there. Vacuum fluctuations. I mean, I don't know if you guys noticed, but I don't think there can be such a thing as a complete vacuum. I don't think there ever could be. I think it's just like a false. It's just a misunderstanding, because we exist in a false vacuum, very obviously, because there's particles out in space. Like, okay, let's just imagine very poorly designed, like, spaceship. I don't know. You're going right through space. Well, all these little like crumbs and stuff, particles. Space is not empty. Now there may be portions that there's less of these, but they're still everywhere. I'm saying even if they're not like hard matter that you can see, they're still very easily, like very tiny, imperceptible particles that you're going to hit. So I'm saying even if you found very, very empty space without the big stuff, it's all the little stuff you're still going to have to worry about. That's basically counting air resistance into your aerodynamic physics equations. But now you're accounting particle resistance. And where do these particles come out of? The rifts. I'm saying dimensions themselves are Casimir plates, but they're like Casimir, I guess, membranes. That's what a dimension is. Casimir membrane. So imagine the Casimir plate experiment, but now it's the fabric of space-time, like the fabric of space-time itself, mimicking the function of a Casimir plate. And I'm saying this rift is happening. Now you may be only observing it on one dimension. So I'm saying if you're coming at something that's wrapped around with this rift in a circular motion, I'm saying stop thinking, start adding depth perception to your stuff. I'm saying you might as well be looking, these might as well be mirrors, is what I'm saying. And I'm saying if you can only visualize this sixth dimension, you might as well be saying, okay, sixth dimension. But which is the sixth dimension? I don't know. Is this the anti-sixth dimension? Or is this the anti-sixth dimension? Well, you have to choose one. And I'm saying, well, just create a number line. Negative, positive. Otherwise, you're going to get yourself mixed up. But remember, just because it's anti doesn't mean like it's negative. It just means that we just had to add a modifier to basically show it's on the other side of the number line. I'm saying this is how you understand what 12 dimensions are mathematically if you just keep validating string theory. Because obviously string theory is the fluctuations themselves, the waves. And I'm saying waves, okay, if you were to look at a string particle this way, I'm saying you think like no matter how wavy it is, because of your inability to perceive much further, you're like, oh, well now it's solid looking, because you're still stuck on the 11th dimension mathematically. I'm saying, wait, zoom in. I'm saying If you zoom in to this point, what are you going to find? I'm saying this is what you really find when you zoom in. When you zoom in on that little piece. I know it's not really to scale, but when you zoom in on that little piece, you're just going to find other particles gravitationally acting, being pulled in a string. It's like you can grab the particles in whiplash or something, I guess. And that's what the interactions between these dimensional membranes, Casimir membranes, are doing. I'm saying it's because there are particles along this entire thing. And they're all gravitationally interacting with each other. It's like having a sun and artificially trying to make your own solar system. So you put like a bunch of Earths around. But I'm saying because you don't understand how to control it, it's kind of waving around, bro. And I'm saying, well, okay, define these waves. And I'm saying, okay, so you can go like, well, this is 1, 2, 3. There's a jut here. There's a jut here. There's a jut here, 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 here. So you would say, oh, 10. There were 10 different. I'm saying that's how you use string theory to deduce a string particle, which I've heard it referred to as a WIMP. You know, Stephen Hawking was talking about that, I suppose. But I'm saying you're essentially looking at how badly it vibrated, I guess. Maybe that's too advanced for people. But I'm saying everything coalesces into a circular shape. You have to realize that. As I said with this, I'm saying you have to understand that these dimensions right here, these Casimir membranes, they act as Casimir plates. But you have to understand this is, perhaps imagine it this way. We're looking at a torus and a torus and a torus and a torus for that 12th dimension right here. I'm saying you're actually looking at more than one dimension. You just needed to shift your frame of reference, right? So and these fluctuations are happening so now you're not seeing it as one line going straight down. You're not seeing it as a side-on view. Now I've shifted it slightly offset for you. So now you can see these Casimir plates were really Casimir circles, okay? With vacuum fluctuations in of themselves. So now remember that rift I was talking about. I'm saying there's a rift in the middle. Right? Casimir experiment. That's where all the particles are coming into existence from, as proven. So I'm saying there's a center point. I'm saying it might as well be this circular event horizon here. That for some reason, this part can't see past, and this part can't see past. Or it's very hard to detect past that. Because I'm saying all these things are it's like the reverse effect of a black hole. Black holes basically stretch everything so thin that it stops everything. It stops time, it stops gravity, it stops light. Nothing can escape this point right here. But this is the opposite effect. it's creating too many things to where it's obscuring. It's making it opaque. Perhaps you could say this is the opposite function. This is what a white hole would do, I suppose. But you know what this looks like to me? It just looks like, hold on, I'll draw it. Okay, I erased some stuff. So this looks like to me what John Archibald Wheeler was saying. Okay, assume we exist in a closed circuit. So it started from somewhere, right? Everyone's like, oh, it started from this Big Bang point. Okay, good enough, whatever. There's a closed circuit, right? Well, you could start saying, oh, well, you could say, okay, this is point A, and this is point B. This is a beginning point, this is an end point. This was when existence happened, this is when existence will end. And you can say, oh, this is a big rip, right? Well, what I've been telling people is, well, what happens at the big rip? Tell me. You go logically go through it all, and it's like, okay, well, everything becomes so disordered and so disorganized and is so far apart and just ripped apart by, the expansion, that everything becomes meaningless. Like, time has no meaning because you can't really discern time. So everything starts to break down, even time. I'm saying this already happens at, remember, the event horizon of a black hole. It just spreads everything so thin, so infinitely thin, or assumes infinitely thin, that it mimics the end state of the universe. So, maybe rather this would be off and this would be on, in bits. But I'm saying it doesn't matter. You're just assigning things to things. That's all you're doing. So this mimics this. But it could also mimic this, because you're like, well, before the universe was, if you assume it's a simulation, before it was turned on, well, it just didn't have anything, right? Or did it have everything that came into existence? That's what I'm saying. Now you start thinking on a vertical number line when you start to see this. It's very hard to conceptualize, but I think this is one of the best ways I can do it. And then, so you got here by understanding string theory, remember? And I'm telling you, it's not A, B, C, D. I mean, you can give each dimension a lettering to define it, sure. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can. But I'm saying it's not your definition. It's not your particles or your numbers that keep the universe going. It's that your numbers, your particles, and all your definitions are the observational effect of the universe's existence. It is the special relativity to the general relativity. I'm not sure if most people get that, but what I'm saying is, like, okay, I started referring to it as K-King theorem, because as like, well, no one's getting past K. They're not recognizing that orange dwarf stars are more beneficial than G-type stars. 7, the Sabbath. We have a G star. But K stars are longer lived. It's because we don't understand how radiation works and how fast life evolves. Because we thought time was a defined thing, but it was just an illusionary effect that we gave a value to. That's what I'm saying. Dimensions, it's not, it's more perceptual. It's not, because I'm saying if you put a 13, then that 0 is just going to shift, but it's still going to have the same properties. It's still going to, the middle point of the universe is always going to pop stuff into existence no matter what. These rifts, these dimensional rifts in the membranes, or you have to understand what's going on there. And I know that's far too advanced, but I'm saying just look at string theory. Every single time you start to doubt, look how far it's gotten you, actually. It got you all the way to K. And I'm saying, if you forget that, you take the L, and the simulation starts to stall. Because what you don't understand is that dimensions 1 through 6, it's like an Ouroboros, right? And if you just count back from 12, if you realize that for every effect, every dimension, for every action, there's an opposite and equal reaction. For everything on this side, there's going to be an anti-side due to Newtonian physics. Then you can understand the strong and the weak forces of the universe here. So every single time you expand your dimensional understanding, then you can understand how there's an anti that. So if you say this is the yin and yang, it's a circular motion, then I'm saying this is the other circular motion. You know, if this is clockwise, then this is counterclockwise. If this is Ouroboros, then this is counter Ouroboros. I'm saying the only way you're going to connect those two is to make a figure 8. Because an 8 is literally both of the Ouroboroses connected. But you're going to have to reconcile the fact that they're both moving in opposite directions here. That's what's creating the fault line in the dimensions. Now, that's probably too advanced for a lot of people. But if you don't realize that, you take the L theory and you keep looking at string theory. Okay? Every single time you can't long live the king yourself with K theory, you take the L. Basically, I'm inventing catchphrases and weird idioms and things, because obviously the layman doesn't understand like all this crap, right? So I'm just saying, hey guys, K theory, you know, because it's just 11th dimensions mathematically with string theory. It's pretty easy to me. That's why I act jokingly to people. JK. You know. Anyways. And it perfectly lines up. I'm saying it is no coincidence that everything lines up perfectly. It's no coincidence. This is when you start seeing the universe as a mechanism, as a machine. It's this self-contained infinity function, if you will. So this is the crux of string theory. Whether it realizes it or not. What I'm saying is, if you turn a simulation on, let's just say the photons didn't experience any resistance whatsoever and somehow got to the other side. Great. But I'm saying not all of them. Obviously, these dimensions created effects that didn't make them take the same path, but they all end up in the same place. I'm saying this is basically what's happening right here. With string theory, you have to consider all possible realities, but they all end up in the same place. I'm saying it's like a dartboard throwing darts at another dartboard. And I'm saying, due to gravitational effects, I don't know if it can break that. You know, this is I'm saying everything you do is going to rebound. It's like a karma function of the universe. Because of gravitational effects in these fields, right? They're basically holding reality together, these dimensions, I guess you could say. And it's like, it doesn't matter how like refracted or like how long the path took through all these different, they don't have to take straight paths, as light does not even take straight paths anyways through a medium. So now imagine having a glass of water. Well, you can observe a quantum effect by just looking at it, because obviously light didn't travel in a straight line through that medium, unless it was like super clear and just like the medium almost visually didn't exist for whatever reason, and it was like devoid of like everything. Then yeah, clear water would make light take a more straight path. But I'm saying the more muddied it is, the more it might wave through the dimensional waves. I don't know if any of that makes sense, but I'm just completing this guy's work. I'm just completing that guy's work using Stephen Hawking's Hawking radiation, by understanding that you could use like even black holes evaporate. So I'm saying even this breaking down of space-time, this big rip scenario, evaporates. I'm saying, so like if you could just see past that, then I guess you could literally do this or something, right? And not have to take that path. And you could literally go around the universe's end and just keep going and go to like I suppose like a hypothetical C point, right? And then you just keep going. Or you can find a way to just go past it, I guess, which might just be the easiest. Which you could say, okay, well, this is an event horizon here, since it's mimicked right here. If the event horizon is mimicked right here, then all this is event horizon, and we need to just go through it. That's probably what a portal is. That's what I'm saying. You won't know until you look into it. What you have to memorize is that it's perceptual, though. You can define it, but be careful how you define it. Are you defining it linearly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? To where you'll just keep adding pi or particles forever? Or are you defining it on a number line, where this is the 0 point is the superposition of states? It's Einstein's, or not Einstein, it's Stephen Hawking's theoretical particle 1 and theoretical particle 2. That, you know, if they create, they get lost. If they create, they get lost. So you have a negative, so you end up with a -2, and you end up, well, I drew this way out, but imagine a 2. So no matter what, there's always an equal force. And these two that get lost come into this new existence and come out, get born out. So they get shot out. And you could say they can't come in through lower, they get lost in a lower dimension and get shot out in a higher dimension, if you will. Now I'm going to stop the video there, because y'all need to keep looking at that. Otherwise you're not going to understand past L theory. The L, 12th dimension. Personally, you know, well, I'm not even going to go there. This is just going to remain scientific or theoretical or hypothetical. Yeah.